Hello friends, in this video we are going to discuss about the different region operations. So for this case we are taking the NPN transistor. In this NPN transistor, see that this junction will be the JC junction and this is the emitter junction. There are two PN junctions. Similarly, here it will be the JC junction and here it will be the emitter junction, and here it will be the JC junction, and here it will be the emitter. Now, for making the transistors to operate in different regions, BJT can operate in three different regions. The first region that a transistor can operate, that is the cutoff region of operation. Second region is the active region of operation, and the third region of operation is the saturation region of operation. These are the three regions where the BJT or bipolar junction transistor can operate. So let us look at for the cutoff regions. For making the transistor operate in the cutoff region, we have to make the JC junction in the reverse bias. You have to make the J junction also in the reverse bias. So we have to apply external potential in such a way that the JC junction will be reverse biased and the emitter junction will also be reverse biased. So for that case, for an NPN transistors, we can see that if I apply a voltage like this in between the B and C, that if we apply a negative potential at the base and a positive potential in the collector, then the JC junction will be reverse bias. Similarly, for the JE junction to be in reverse bias, can connect a negative potential here and a positive potential to the emitter. So this will be the voltage of VCB, and this is the voltage that is VEB. Now this transistor will operate into the cutoff. In the cutoff region, we can see that the collector junction is reverse biased and the emitter junction is also reverse biased. And in this case, the cutoff region, the case of cutoff region, the equivalent circuit of this transistor can be drawn like this. This is the base terminal, and this will be the open circuit because it is reverse biased, and here it will be the emitter terminal, and similarly here the JC junction is reverse biased, so the collector junction will also be. So this is the equivalent circuit diagram of the NPN transistor when it will work in the cutoff region. Now let us see what will be the active region. So for active region operation, we have to make this JC junction in the reverse bias condition and this JE junction in the forward bias condition. For that, we have to apply here a positive potential with the base and a negative potential with the emitter. So here it will be VBE. So when we have to make the JC junction reverse bias. We have to connect the positive potential with the collector and the negative potential with the base to make the JC junction reverse bias. So we can say it is the voltage. So now this transistor will operate in the active region of because the collector junction is reverse biased and the emitter junction is forward biased. Now, the equivalent circuit of this transistor acting in the active region can be represented by this diagram, that is the JE junction. So there will be the base terminal and the JE junction, which will be the forward bias, will be represented by a PN diode, which is forward bias mode. So this is my emitter terminal and IE current is flowing through this diode. There will be a base current that will also flow through the base terminal. And the JC junction is replaced by a current dependent current source such that the value of this current dependent current source will be alpha into IE, where the this terminal is the collector and the current flowing into this terminal will be the IC, and this alpha into IE current dependent current source can be represented by also beta into IE. So this is the representation of the bipolar junction transistor NPN when it will work in the active region. So, so in the last case, we will talk about the saturation region of operation. Make the JC junction, we have to make this JC junction forward bias as well as the JE junction also forward bias. For that, we have to give a potential in this fashion that emitter terminal should be given negative potential with respect to the base terminal. It is VBE potential as well as the collector terminal will be given negative potential with respect to the positive potential of the base. So this is C. So we can say now the transistor can operate in the saturation region. And in the saturation region, we can see both the junction will be in forward biased. So the equivalent circuit of the transistor in the saturation region can be drawn in this fashion that both the junctions in the forward bias, so they can be represented by a short circuit and there is a emitter terminal. So this is the JE junction which is forward biased. Similarly, the collector junction is also forward biased. So this is the JC junction and this is the collector. This is the equivalent circuit of the transistor in the saturation region, and in this way the transistor can be operated in different three regions part of active. Thank you.